2.8, the distributive property. So this is a really important property. We've learned about commutative property, and this is the distributive property. There's a few other properties as well that we can cover at a different time, but for now, the distributive property is a really important one that will weave itself through everything in algebra. So it needs to become automatic, but obviously you haven't learned it yet. So let's start with a picture. In this picture, you see two boxes. There's three separate pictures here. Two boxes and three dots. And we remember from class that the boxes represent an X. We don't know how many dots are in that box, so we call it X. And the dots represent 1. So this representation would be 2x plus 3. There's other ways to write that. You could write x plus 1 plus 1 plus 1. But the best way to write it, the simplest way to write it, is 2x plus 3. Hopefully you can see the 2x's here and the 3 here. Okay, so if I move to this picture, there's lots of ways I could write this too, and I let you kind of do whatever you wanted in the beginning of the chapter. But now we're going to start to try and tighten it up and do it the simplest way possible. So there's two ways that I love to see you write this. One is you count up the x's and you say, oh, okay, there are 4 x's plus how many dots? 1, 2, 3, 4, 5, 6, 6 dots. Okay, excellent. That's one way to write it in its simplest form. The other way to write it would be that I have two groups of what? Two groups. This is the first group. This is this. I shouldn't use a dot, huh? This is the first group, and this is the second group. Okay? What are my groups made up of? Well, I have two groups of 2x plus 3. Remember up top, I had one group of 2x plus 3, but now I have 2 rows of it, or 2 groups of it. So what the distributive property is doing is it's showing you how to move from this format to this format. Okay, I have 2 groups of 2x plus 3, and that equals 4x plus 6. Well, does anyone see a way that we can connect these? You could do, I have 2x plus 3, and I have 2x plus 3. And if I put my 2x's together, I have 4x. If I put my 3's together, I have 9. So it's, 6. Let's go back. 3 times 3 is 9, but 3 plus 3 is 6. So I have 4x plus 6, which is what I got over here, right? Right. Okay, another way to look at this would be, I have 2 groups of this, so what if I multiplied 2 times 2x? Well, 2 times 2x, or 2 groups of 2x, gives me 4x. 2 times 3 is 2 groups of 3, or 6. So I could use multiplication to do it, which is in fact the distributive property, making that connection. Okay, here, let's do it the fastest way possible. How many groups do I have? I have 3 groups of what? 2x plus 3. Okay, so what do I have total? Well, you could count it up. Let's count it up. 1, 2, 3, 4, 5, 6 x's plus 3 dots, 6 dots, 9 dots. There's my 9. 6x plus 9. That's if I just counted it. But if I didn't have the picture, I could multiply 3 by both of these things inside the parentheses and get the same thing. 3 times 2x would give me 6x. 3 groups of 2x. 3 groups of 3 would give me 9. 6x plus 9. Okay, so let's move on to doing it without a picture. Now I have 7 groups of x plus 9. Well, I could list out 7 groups of x plus 9. That would be the long way to do it. Here's 1 group. Here's 2 groups. Here's 3 groups. Here's 4 groups. Here's 5 groups. Are you tired yet? Here's 6 groups. Here's 7 groups. So I could add it up 7 times and get my answer. But that's crazy talk. I can't do it that way. That's going to take forever. So instead, let's use multiplication. That would mean I have 7 x's, or 7 times x, which is 7x, plus, I recopy my sign in the middle, 7 groups of 9, and 7 times 9 is 63. x, 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 7 groups of x's, so it's 7x, 9, 9, 9, 9, 9, 9, 9, 63. Okay, this method is going to take too long, so let's try to move to this method. I've got 4 groups of x plus 5, so if I multiply 4 times x, I'll have 4x. If I multiply 4 times 5, I'll have 20. Frequently, people forget the sign in the middle, so don't forget to recopy 4x plus 20. I can't add x and 20 together because remember this was counting squares and this was counting dots. So we're counting 2 different things, so I have to leave it as 4x plus 20. Okay, try the next one. Think about what you think it might be. I like to draw in these little rainbows, I call them, but they are optional. This one would give me 15x plus 35. This one here, use the rainbow or taste the rainbow. That would give me 32x. And the one that's tricky here is that there's a minus. So now I write minus, what's 8 times 3? 24. So I've successfully on this whole page, with the exception of this repeated addition here, used the distributive property. Another way to think about it is think of the word distribute. If I distribute the papers to the class, if I distribute the homework to the class, do you think I would forget to give it to someone? No. So if I'm going to distribute the 5 into the parentheses, I'm going to give that 5 to the 3x. I'm going to give that 5 to the 7, which means I'm going to multiply the 5 by both things in the parentheses. Okay, another thing you're going to see in the homework is they do this with numbers. They say, well, how can I use the distributive property to do this with numbers? 5 groups of 28. Well, you could do it the old way and do 28 times 5 and work it out like that. But I'm asking you not to do it that way. I'm asking you to do this using the distributive property. So I'm going to think of a way to write 28. I'm going to recopy the 5, but in the parentheses, I'm going to write 28 the way you did in elementary school. 20 plus 8. This helps you to do the math mentally, actually, because now I've got 20 plus 8 gives me 28, and now I can multiply 5 by 20, or distribute 5 into the parentheses, and multiply 5 times 8. So 5 times 20 is 100. 5 times 8 is 40. I put a plus in the middle, and I've got 140. So 5 times 28 is 140. And guess what? You might have been able to even do that in your head. But please don't on your homework show the steps. Okay, this one is 35 times 7. So 7 is the single digit, so I'm going to keep 7 on the outside. I'm actually going to switch these because they have commutative property, so it doesn't matter. My outcome will be the same if I switch the order. So I'm going to write it as 7 times 35. Then I'm going to keep the 7 where it is, and I'm going to write 35 in expanded form, like I did with 28. So that would be 30 plus 5. And then I would distribute 7 into the parentheses. This time my rainbow is going to go underneath. 7 times 30 and 7 times 5. 7 times 30 is 210. 7 times 5, 35. Math is a little harder to do here, but 210 plus 35, if you think about for a minute, shouldn't be too difficult. 245. Again, you could have done 35 times 7 like you did in the old days, like this, and stack it up and do that kind of thing, or you could use a calculator. But the point is getting used to the distributive property. Okay, so if I were going to write the distributive property as a rule, okay, this is going to be important when you're doing your note to self. The distributive property as a rule, I'm going to write it using algebra. I've got A on the outside and B plus C on the inside. What would this turn into if I use the distributive property? Now, if you're writing your note to self, hopefully you're going to know exactly what to write. But the first time you're seeing this, you might not. I'm going to show the rainbow because it helps remind you that the A has to be multiplied by both things in the parentheses. So A times B, AB. The plus gets replaced, and A times C, AC. And I cannot do any more than that, okay? So that's the distributive rule. That's the distributive property. And you can write it using algebra. And I think it would probably be good in your note to self to explain it using words. Okay, moving along, there's going to be something called the undistributive. But that's not the official name. I just called it that, and I think he calls it that in the book. But if you work backwards, the distributive rule will also work the opposite direction. So let me show you what I mean by that. Undistributive. Again, it's not really a mathematical term. But what I want to do is I want to make this expression look like it did before I distribute it. This is for sure the harder rule, and I believe he even says in there that he's not sure he should even teach it now. So it's a little early to teach this. So if this is confusing to you, just try to follow along. All right? So what number would be outside the parentheses that I would distribute into the parentheses? Then I would get 10x plus 5. Well, the number out here has to be a factor, or the greatest common factor, of what number goes into 10x and into 5. Well, it's 5. So I draw my skeleton, my empty spots, and now I try and fill it in. And if you were ever on a test, you could just draw this if you weren't sure what the numbers were, and this would give you partial credit. Okay, so 5 could go on the outside, right? And then I look and I say, okay, 5 times what gives me 10x? Well, 5 times 2x would give me 10x, right? 5 times what would give me 5? 5 times 1 would give me 5. And now I've done the undistributive. I've taken this expression and I've written it as though I had a number outside the parentheses and an expression inside the parentheses. Okay, let's try this one. I'm going to have a number outside, I'm going to have parentheses, and then I'm going to have something inside plus something else. Guess what? I just got partial credit. Okay, the number that goes here is going to be the GCF of my two terms here. So I've got 30C and 6. What is the GCF? What goes into both of these? 6. Okay, 6 times what gives me 30C? 6 times 5C gives me 30C. 6 times what gives me 6? 6 times 1 gives me 6. Okay, I've completed the undistributive. Okay, last one. This one here is going to have blank, parenthesis, blank, minus, notice the minus here, blank. Okay, I just got partial credit. If I'd put a plus, maybe not gotten partial credit, I don't know. Again, the GCF, what goes into 45 and 15V? 15 does. And it may take you a minute. You may have chosen 5, which would have been right, but not maybe all the way right. You want to get the biggest number you can to suck out of these two. So 15. 15 times what gives me 45? 15 times 3 gives me 45. 15 times what gives me 15V? 15 times 1V gives me 15V. Okay. That concludes distributive property. Again, the hardest part of this is the undistributive, but overall, this is kind of a tricky concept, and then when you get good at it, I think you'll start to really like it. Okay, thanks. That's all for now.